Okay, these are intro to derivative notes. We're going to learn some basic rules about taking derivatives. So we could call a derivative y prime, f prime of x, or something like dy dx, change in y over change in x. That makes me think about a slope, and in fact, a derivative does give us the slope at a point on the graph. It gives us the slope of a tangent line. First rule, the derivative of a constant is 0. So a derivative is a slope, and if our function is some constant, like f of x equals 3, that function would be a horizontal line. Its derivative, its slope, would be 0. So the derivative of a constant is 0. So they give me f of x equals -3, f prime of x is going to equal 0. The derivative of the function y equals 4 is 0. Okay, so here's a power rule. So here's the power rule in my own words. I'm actually going to go down to the bottom of the screen and write it, and we're going to use this power rule to find some derivatives. So in our own words, we're going to multiply the power to the coefficient, and then we're going to subtract 1 from the power. So this is how to take derivatives using the power rule. So the first one here, it says find y prime if y equals 13x. Well, the power on the x is 1. So we're going to bring that power to the front and multiply times the coefficient. So 1 times 13 is just 13. Let's subtract 1 from the power. Well, it's currently a power of 1, so that's going to give me 13x to the 0 power, but x to the 0 power is just 1. So the derivative of 13x is 13. Okay, over here, next one, we're going to do the power rule here. We're going to multiply the power to the coefficient. So it's going to give me 6. I'm going to reduce the power by 1. Okay, next one. I'm going to move the power to the front and multiply it times the coefficient. So f prime of x is going to equal 7x. I subtract 1 from the power, so my new power is 6. 7x to the 6th power. Okay, the next example, we need to do a little work before we can apply the power rule. So I'm going to rewrite this as 3x to the 2/3 power. If I want to use a fractional exponent like that, I do power over root. So this is our original function. Our original function is 3 times x to the 2/3 power. So when we take our derivative, we're going to bring the power and multiply it times the coefficient. So I'm bringing the power down, multiplying it times the coefficient, and then I subtract 1 from the power. So 2/3 minus 1 gives me -1/3. Okay, so that's my derivative. I'm going to clean it up a little bit. It's only required to clean it up if the directions say to. So I'm going to go ahead and cancel those 3's. So I have 2x to the -1/3 power. So I'm going to get rid of that negative exponent by bringing the x to the denominator. And I'm going to put this in radical form. So when I put it back in radical form, I do power over root, and that shows me that it's a cube root. So 2 over the cube root of x. Go ahead and pause the video, try these next few, and then you can resume the video and check. So I'll give you a few seconds to start pausing the video. Okay, so taking a look at example 1, I got an answer of 48x cubed. Make sure you label your answer as f prime of x, to denote that it's a derivative. Number 2, y prime is equal to 20x to the 4th. Now, on number 3, I rewrote the original function y as x to the 1/5 power. So then I could see to do my power rule, and then I rewrote it without the negative exponent. So either of these answers are correct. Just pay attention to the notation that's required on the assignment. On number 4, this is the original function. And down here at the very bottom of the screen, I found the derivative using the power rule. And lastly, I rewrote it without the fractional exponent. Okay, so we are also learning to take derivatives of common functions. So some derivatives to memorize are shown here. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. I'll let you read these other ones here. We're going to use those in a second. Now, part D says the derivative of a constant times a function is equal to the constant times the derivative of the function. So coefficient just kind of carries through when you differentiate. So the derivative here of 9e to the x, well, let's go ahead and look at the top of the screen. The derivative of e to the x is e to the x. So the derivative of 9e to the x is 9e to the x. On the right hand side here, it says f of x equals pi sine x. So I'm going to take the derivative of sine x, which is cosine x. That coefficient of pi, since it's a constant, just a coefficient, it carries through when I take the derivative. Okay, next, the derivative of 5 cosine x. Well, looking up here at the top of the screen, the derivative of cosine x is negative sine x, and that coefficient carries through. If you wish, you can rewrite this as negative 5 sine x. Okay, if we're taking the derivative of some sums and differences, so some different terms added or subtracted, we're just going to take the derivative of each term separately. So, go ahead and pause the video and try both of these. And then you can resume and we'll talk a little bit about what we got. So go ahead and pause the video and try both of those strings of derivatives. Okay, so taking a look at those derivatives, I don't think anything's probably too surprising. On this first one, that last term, we can rewrite it without the negative exponent. So here's how I got that derivative. Square root of x is the same as x to the 1/2 power. I applied the power rule by bringing the 1/2 to the front and subtracting 1 from the power. So that gave me the derivative back here as the derivative of square root x. We're going to use the derivative of square root x repeatedly this year. So it's my suggestion that you memorize the derivative of square root x is 1 over 2 root x. 1 over 2 root x. So you're going to get these derivatives at the top of the screen memorized. I would go ahead and memorize the derivative of square root x. Okay, and looking at the bottom one, I just took the derivative of each term separately. If required, you would have to rewrite this without the negative exponent. And so we'd bring it to the bottom and make it 2 over 7 times the 7th root of x to the 5th. This last term could be expressed as 5/2 times the square root of x cubed. Okay, so that only is required if the instructions say to do that. Okay. So in this lesson, we've only learned 2 ways of finding derivatives. Using the power rule, and then using the derivatives of functions that we're just going to memorize. So for example, the derivative of sine is cosine. The derivative of 2 to the x is 2 to the x power times ln 2. So two main methods of finding derivatives in this lesson. Power rule and derivatives we're going to memorize. So in there's a product happening. And there's a product rule, but we don't know it yet. So before I can take the derivative here, since I don't know that product rule, what I'm going to do is I'm going to distribute the x squared. So distributing the x squared here, I get 2x cubed. Distributing the x squared there, I have to add the powers. So x squared times x to the 1/2. Adding those powers, 2 plus 1/2 is the same as 5/2. So I have x to the 5/2 power. This is not the derivative. I'm just rewriting it so now I can take the derivative of each term. So taking the derivative here is using the power rule. I multiply and subtract 1 from the power. And then I'm going to have 5/2 x to the 3/2 power. Again, we have to distribute because we don't know the product rule yet. There is a product rule, but we just don't know it. Okay, on this next example on the right-hand side, before I take a derivative, I'm going to go ahead and rewrite these as powers of x. So I'm rewriting this as x to the -2, x to the 4x to the -3, and pi x to the -4. Now that we've rewritten the problem so that it has terms of the form a coefficient times x to a power, now we can, there's the cat. We can go ahead and use the power rule to take our derivative. So we're going to label this now f prime of x, bring the power to the front, subtract 1 from the power. Next term, bring the power to the front and multiply to the coefficient, subtract 1 from the power. And lastly, multiply the power to the coefficient and subtract 1. So that's the derivative. Again, you might be asked to rewrite it without negative exponents. In that case, the coefficients would stay in the numerator and you would bring those powers of x to the denominator. And as a result, you would get rid of those negative exponents. Okay, one last one. So on this guy, if there's a single term in the denominator, what we can do is we can rewrite it as two fractions with that denominator of x squared. So I'm rewriting this expression as two fractions and giving them both the denominator of x squared. Why am I doing this? Because I have to have my expression in the form of a coefficient times x to a power in order to do the power rule. And we know very few ways of finding derivatives, so for now, we have to use the power rule a lot. Okay, so what I'm doing here is I'm subtracting the exponents, and I'm going to get x to the first power. Here, I subtract the exponents, and I get 4x squared. This is not the derivative. This is still f of x. All that I was trying to accomplish here is rewriting it so I can take the derivative. So now taking the derivative, we're just going to be left with the 1 minus 8x. So one important thing to note is that you want to give a name to the derivative. F prime of x equals the derivative here. But on this previous example, this means the derivative of. So the derivative of this function equals something. So that's proper notation also. So on these derivatives I told you to get memorized, the derivative of sine x equals cosine x. Just a little conversation about notation. All right. Thank you, Math Stars.